All right, so this little unit here is going to be about word problems. It's it's all the stuff that we've done up to this point on the triangles, but we're making word problems out of them. All right, so we might be solving for angles, we might be solving for sides, but it's word problems. That's all it is. So there's two two terms here that come up a lot in these word problems, and if you don't know the difference, they become kind of confusing. So there's angle of elevation and there's angle of depression. So I think we kind of all agree that depression makes your mind, think more of a downward position, uh, whereas elevation kind of makes you think upwards. So what an angle of elevation is, it's it's the measure of an angle. It's always from horizontal, so from horizontal pointed upwards. All right, so they're measuring this angle, and it's pointed upwards. So it could be facing like that, or it could be facing like this. All right, so from horizontal, it's pointed upwards. Whereas an angle of depression is the opposite, it's pointed downwards. So from horizontal, they're measuring it downwards. All right, I guess it's kind of like whenever we looked at angles in standard position, an angle of elevation is kind of like a positive angle. Right? Remember, if it goes counterclockwise, it was positive. And if it was an angle of depression, it would be kind of like negative, where it goes clockwise. So here we go. First example. So a nursery, they plant a new tree, and there's a guy wire that's attached to it to help support the tree. All right, so first let's try to build a little tree here. All right, here's our tree. All right, so the wire is 8 foot long, and it is attached to the tree and to a stake in the ground. All right, so from the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. So find to the nearest tenth of a foot the height of the connection point on the tree. All right, so somewhere on the tree they've attached a wire up there, and the wire can go down either way here. Doesn't matter. I'll go off to the left here. I have no idea if I'm doing this on the right side. It's not a big deal. It says that the guy wire is 8 foot long. All right, so we know that distance is 8 feet. I'm guessing, because we're in right triangle land, that we've got a right triangle here. All right, so from the stake in the ground, so here would be the stake, the angle of elevation in connection with the tree. So it's an angle of elevation, so they're measuring it upwards. So that angle is 42 degrees. All right, so if they were talking about this angle over here, they would have called it an angle of depression because it's pointed downwards, whereas this one is pointed upwards. All right, the question is, what is the height of the tree, or what's the height of the point of connection here? All right, so we've got an angle 42. The side opposite is x, and we know the hypotenuse here is 8 feet long. So I'm going to use sine of 42 is equal to opposite over hypotenuse. To solve here for x, we're going to multiply both sides by 8. So we get 8 sine 42 is equal to x. So 8 sine 42. 5.35. Yeah, it said to the nearest tenth of a foot. So it would be 5.4. All right. So about 5.5 feet up there. That's where the connection is made. All right, next question here. We'll try to squeeze 2 examples in this one. All right, so from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression. All right, so the guy's standing right here, and he's looking at his friend down on the ground, and that angle is pointed downwards. All right, that is an angle of depression right there. If the tower is 45 feet tall, how far from the base of the tower is his friend? All right, so one thing you kind of want to keep in your tool belt is that if you have an angle of depression or an angle of elevation, you want to think about complementary angles. All right, so we can see here that this makes up a 90-degree angle. Well, if we know that this is 40, then this missing angle down here has got to be 50 because they add up to 90 degrees. All right, so you could work with that angle if you wanted to. You could call this a 50-degree angle and work off of that. All right, another thing that you can use here is alternate interior angles. So notice the base of the ground here. All right, it's parallel to his line of sight this way, his horizontal view. And so because of that, you've got two parallel lines, and this line here is going to act as a transversal. And so you can talk about complementary angles, alternate exterior, all those. Basically, this 40-degree angle and this angle down here, 40 degrees, are alternate interior angles. So they're equal to each other. And then from there, if you wanted to, you could get the 40, 90, and you could get the 50 degrees that way if you wanted to. Up to you. I'm going to work with this 40-degree angle here. So if I'm looking from 40 degrees, I've got my opposite over my adjacent. So tangent of 40 is equal to 45 feet over x. All right, so if you multiply by x and then divide by tangent of 40, you're going to get 45 over tangent of 40 is this horizontal distance. All right, so 45 divided by tangent of 40 is 53 point, let's see here, to the nearest tenth of a foot. So it'd be 53.6. All right.